Right. Welcome back. I'm not sure if you heard the pause music. I don't think you would be able to hear that, but hopefully this doesn't get copyright striked. Um, yeah. Welcome back to another advent of code. I think I bumped the mic there. As you can see, it's quite a bit darker here today. And if I go to this light, this camera, you can barely see some Christmas lights in the background. It's actually, it looks way darker on camera than it does in real life. Because I have the exposure set quite low, and then I'm quite sharply lit to just dim the background down a bit. Right. Anyways, Advent of Code Day 9. I haven't looked at this. Same procedure as always. It seems that it has revealed more of the cave down here when it unlocked Day 9. Yeah, let's get into it. Right. I'm just gonna post this to off topic as well real quick. There we go. Oh yeah, by the way, I got, let's see, I go to, is this still on? Nope, not at all. If I go to this one, I got these in the mail today. So for those of you who don't know, this camera's just horribly out of focus. This is the old Nim mascot, just the head with the new Nim crown attached to it. And it is something that I've been using as, so it's defunct as the Nim logo. It was never really used as the Nim logo. I think this is the first ever sort of print that's been done of it. It was I think it was Sticker Mule who had a campaign for like $1 you could get 10 3x3 stickers. These are actually pretty big stickers. They were way bigger than I expected. They said 3x3 inches, and I used the metric system, so I don't really know how big that is. And I didn't, like, it was $1, so I didn't care to calculate how big it was. If I knew they were gonna be this big, I would maybe have tried to like do 4 of them on the same sheet and then just cut them up by hand. But yeah, I've got 10 massive Badger stickers. So I use it as the logo for Badger, my keyboard firmware. So yeah, if I were to print them out again, I think I would ease up on the contrast a little bit, because they are not sure how well this comes through, but the black here is quite black. Like the dark parts is quite black, so it doesn't quite look the same as on screen. So maybe I would have gone for a slightly lighter color. But yeah, anyways, Advent of Code. People are joining the stream. It always takes a little while before people start clicking the link. So I don't want to say, I don't want to get right into it, because then people are gonna miss out. Day 9, Smoke Basin. These caves seems to be lava tubes. So lava tubes is sort of the path that lava has taken after all the lava has run out. pretty cool geographical feature. Or geological feature, I guess we would say. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. Oop. This was originally going to be a puzzle about watersheds, but we're already underwater, right? If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you, which is my puzzle input. Smoke flows to the lowest point of the area it's in. For example, consider the following height map. Each number corresponds to the height of a particular location, where 9 is the highest and 0 is the lowest a location can be. Your first goal is to find the low points, the locations that are lower than any of its adjacent locations. Most locations have 4 adjacent locations, up, down, left, and right. Locations on the edge or corner of the map have 3 or more adjacent locations, respectively. Diagonal locations do not count as adjacent. So as you can see here, this 1 is lower than this 2 and this 9 and this 9. This 0 is obviously lower than anything. This 5 is lower than this 8 and this 8 and this 6 and this 6. And this 5 is smaller than this 6 and this 6 and this 6. But for example, this 2 is bigger than this 1. And this 1 is bigger than this 0. Other small numbers here. This 3 is bigger than this 2. So that's not a low point. So yeah. In the above examples, there are 4 low points, all highlighted. 2 are in the first row, 1 in the 0, 1 is in the third row, 5, and 1 is in the bottom row, also a 5. All other locations on the height map have some lower adjacent location, and so are not low points. The risk level of a low point is 1 plus its height. In the above example, the risk levels of the low points are 2, 1, 6, and 6. The sum of the risk levels of all low points in the height map is therefore 15. Find all of the low points on your height map. What is the sum of the risk levels of all low points on your height map? Right. So we can get our puzzle input. Obviously, it's way bigger than our little test there. Input.txt. And then we can just grab this as well, the test. I like to do this, have the sort of example inputs. We can verify our solution against the one that is given here, which I think is a good way of debugging these. I actually want to have a look at the input here. So it seems to be 100 by 100. Yeah. So you can see down in my bottom right corner here, I have a position count. So position 1, position 100. I took a screenshot by accident. And of course, you can see the lines on the left. So it's 100 down and 100 across. This one, the input example, is only 10 across and 5 down. So what we could do, I'm going to do, well, actually, I don't think we need stereotils for this. So, I mean, we could, if we only wanted to do this one, we could have an array of 100 by 100. But since we're doing this, I'm thinking a sequence. Or we could do like the infinite one and say, so like a table, for example, and store them by location. But since this is densely packed with data, like every point here is a relevant point, and not like the one with the lines, for example, where most of the lines or most of the area was empty. I think this makes more sense to store in an array or a sequence of sequences. You can hear that in the background. That's the dog. Lotte. Dog digging in my sofa. I'm watching my mom's dog. Lotte. Just a second. Lotte, come here. Come here. I tried to get her over here, but she didn't want to come. And I couldn't reach her. Right, so our map is just going to be a sequence of sequences of, I guess we could just do characters, or we could do them as uint8s. And then we can say for line in lines of input example to begin with. So this just iterates over all the lines. And then we can say map.add. So at the beginning, it's going to be 0 length. So we add the lines as we go. Line dots. This will be a string. I wonder if we can do a map. I'm gonna call this something other than map. Call it grid instead. Line.map. I wonder if we can do this. Map it, and then say it.ord, which is the number for a character. So that would be, so these are the ASCII character numbers, minus the ord of a 0. That should give us the number as an int of a single character. But I'm not sure if that works. Right. That apparently yields an int. I'm just going to do uint8 because we don't want to store a full 64-bit integer to store something that is basically a 0 to 9, which could be stored in just a couple of bits. So if we now echo out the grid, we should see I haven't actually done this before. So there we go. Right. So this looks about right. We have 5 lines, and yeah. So now we can do a loop over for x in grid 0.length. Actually 0 dot dot and then do high, and do the same for our y here. For efficiency, you would swap these around because you really when we're looping over stuff like this, because of cache locality and stuff like that, you always want to go through one sequence, like your inner sequence. You want to go through quickly. So in this case, we're going to be looking through this. We're going to do that sequentially instead of going like up and down, which would be out to the outer sequence. It doesn't matter for this, but so now we can just say, so we can very quickly verify if it's the smallest one in the area, because that's just index checks to the surrounding pixels or positions. So we can just add the risk in as we go. So if y is larger than 1 or larger than 0, that means it's 1 or more, then we need to check the up pixel. And we just set smallest to true here. And of course, then at the end, we're going to do if smallest risk plus equals grid y x plus 1. Because the risk was the position plus 1. So 1 plus its height. And this would be the height, and this would be the plus 1. But now we need to set smallest to false if it's not the case. And we only need to do this once. So we're going to create a named block here. And we can do if y is larger than 1, then we want to check the one above us, because we have one above us. Or it's larger than 0, sorry. And then yeah, we do if. I'm doing this mostly to show off the block function. There's definitely a better way of doing this. So if this grid is smaller, and let us store our current one here, so we don't have to do that every single time, because we're going to be using that quite a bit. Current. So if that one is smaller than current, then we set smallest is false, and we're going to break out of our check. Of course, we don't have to break out of the check, because the way we're going to write this, smallest is never going to be able to be turned back into true. But, you know, I just want to show off that feature. So if y is smaller than grid.high, so if it's not the largest position, we check this one. And then we just do basically the same thing for x. If x is larger than 1, then we want to check x minus 1. And similarly, if x is smaller than grid 0.high, then we want to do x plus 1. There we go. And right. So risk here is set to be an integer, and it probably has to be because this number is going to grow higher than 256. But current is a uint8, so we have to convert that into an integer. Nim is quite strict about types, even numbered, like numeral types like this. Now echo out the risk. We can see that the risk is 15, which is what we expected from the example. So now if we run this on the actual input, we can get our actual result. So this should be the result for my puzzle input. Oh, it's not the right answer. My answer is too high. If you're stuck, make sure you're using full input data, blah, blah, blah. Okay, so that was apparently not right. What did we miss? So we assume that we're the smallest, and then we run these checks. So it's if x is larger than 0, check the one. Is y is larger than 0, so if we're not on the top line, we check the one above us. If it's smaller than current, then the current is not the smallest one, and we break out of this check. And now we're down here. Actually, what we could do, we could remove the smallest variable, and we could just do the break, and we can put this inside. So by just removing that, this is already indented. So now this is inside this check. So if we get to any of these, we're going to break out of the check statement. And now all of a sudden, we're not in the risk one anymore. I'm guessing, do we possibly have an adjacent, like two numbers of the same size, and it's a matter of being that we're equal. Locations that are lower than any of its adjacent locations. So if this is lower or equal to us, then we're not the lowest, and that means we will have we're not a low point. So 607 might actually be our right answer. Just to show that the logic here, the rewrite I did was correct. This still would give us the same answer. But yeah, 607. It did complain it was too high, so that might be right. Yes, okay. That was the right answer. So we're one gold star closer to finding the sleigh keys. Christmas might yet be saved. So yeah, it's similar, like we could have defined the smallest variable and then just have set it to false and run all 4 of our checks and then check the smallest variable. But by doing it this way, we only run until one of the checks are false. So we sort of break out early from our tests here. So this is not quite the go-to statement, because go-to statements are super messy to reason about when you're like for the compiler. So this is sort of it kind of serves the same purpose as many of it kind of serves the same purpose as go-tos, but it's a bit easier for the compiler to reason about, and in my opinion, a cleaner solution. We could, of course, these named blocks that you can break out of can also be used to break out of a double nested loop, for example. So if I just did break here, it would break out of this loop. But if I wanted to break out of both loops, in some languages, you then need to define a variable that you set to false, and this loop checks that variable, or it's a while loop that checks the variable. So to break out of both loops, you have to set that to false, for example, like set continue to false, and then break out of this loop, and that will trigger the check in this loop that will break out of that loop. But with this block statement, we'd actually break out of both loops with just a break block or break a named block. So that's pretty cool. Anyways, let's copy part 1 over to part 2. Nope. And then part 2, I'm going to refresh the files here so it shows up. There we go. Okay, this is probably going to be a bit trickier. Next, you need to find the largest basins so you know what areas are most important to avoid. Right, so now we're sort of mapping a bigger area around us. A basin is all locations that eventually flow downward to a single low point. Therefore, every low point has a basin, although some basins are very small. Locations of height 9 do not count as being in locations of height 9 do not count as being in any basin. And all other locations will always be part of exactly one basin. The size of a basin is the number of locations within the basin, including the low point. So the example above has 4 basins. This one is a 2, 1, 3, and these 9s sort of stop it. That's a size 3. And the top right basin is a size 9. So these ones, until it reaches this 9, and this 9, and this 9, and down here, and this 9, and this 9, and this 9, and this 9. That's part of this basin. the middle basin, size 14. All of these. And there. So that's a pretty big one. And the bottom right basin is a size 9, which is this basin right there. Find the 3 largest basins and multiply their sizes together. In the above example, this is 9 times 14 times 9 is 1,134. What do you get if you multiply together the sizes of the 3 largest basins? Oh, the 3 largest ones. Interesting. Okay. Interesting. Sizes of our 3 largest ones. That's an annoying sort of extra condition, because that means we can't just multiply them or just sum them up as we go. Right. So in this example, all of these basins are sort of delimited by 9s. Now, technically, this is not a requirement, because they have to flow downward to a single low point, and all of the locations will always be part of exactly one basin. So it doesn't mention that explicitly, but I would assume that that is, in fact, sort of the scenario here. Can I highlight 9s? There. Yeah. So you can see like this would be a basin to this one here. This would be a basin to this 2. This is a basin to this 4, I guess. So yeah, it seems to be, there seems to be 9s sort of covering all of them. Like I don't see another 0 in this basin, and the basin is just like delimited by the middle point between them. That would make this way harder. So yeah, I guess when we find a basin, sort of do a flood fill thing where we just go outwards until we reach 9s. We can probably do that with some recursion. 9s are the edge of the board, obviously. So the way, like, we could do this recursively, just say, go to all these 4 positions, and then go to the 4 positions of this one that are not already visited, and then like do that sort of recursively. There probably are some better algorithms for this, but we are not gonna run into a performance issue here, I don't think. Oop, now I'm in the part 1 file, in the part 2 file. So now we want to calculate basin size. We can do this as a func. So that's a function. That's a mathematically pure function. It only takes inputs and it returns something, and it can't modify any global state or any of its arguments as long as they aren't passed as a var or its reference object. So for basin size, we are actually going to be using some sets, I believe, because we need to know, like, to calculate the basin size. If you go back to our input here, this one. So to calculate the basin size, we have to know the position, all the positions that we have visited. And to do this, we need to, so the algorithm I mentioned, if I go to the right one and then visit all the positions given by the right one that haven't already been visited, we need to know that this one has been visited. So when we call this function, we need to pass in sort of a list of every visited position. But we don't want to have a list because that takes a long time to iterate over. So what we're going to do, we're going to be using the sets module, and we're going to use a hash set. Again, that was the part 1. I'm just going to close this part 1 file. We're going to import the sets module, and then this is going to take a base in points is a hash set of a tuple with an x and a y position, and this is going to return a hash set. So we're just going to say that the result is the basin points. Again, we can't modify this this basin point. This sets module. Just want to check that hash set. Yeah, hash set is an object, so that is not a reference type. This will copy basin points into our result. And then we want to basically do something similar to this. So we want to go, we also, of course, need to take an X and a Y position. And these positions, we're gonna, just take those in as integers. So we know that XY has already been visited. That is an assumption we're going to make. Well, actually, let's not make that assumption. So if our grid, so we can look, can we look at global memory in a function? Not entirely sure. Let's find out. So we're going to look at XY. If this is not the number 9, or if it is the number 9, just return. So if you find a 9, this function just returns. And since we have set result here, this is going to return just the same points that we came in with. Otherwise, we need to check, we take our result and we include the tuple of our X and Y position. So this point is good. Now we want to do the same thing for the right, the up, the down, and the left. And since this is included, we want to avoid an infinite loop here. So if basin points, the points that came into the function, and the rest contains should be good. If basin point contains X and Y, so if this has already been visited, we just return. Actually, we can do that. We can actually do that sort of, yeah, up there. And we can actually do this just in an OR. So if X is 9, or the basin point is already visited, we return. Otherwise, we're gonna include it as visited, and we're gonna visit all other points. I'm just gonna copy this logic because that is just the grid checking logic. So if we're larger than 0, we are going to check the position above us. So we're going to do result plus equals. I'm not sure if that is defined for sets. But we're gonna do basin size of x plus 1 and y. Of course, the other way around, because that's how we have defined our function. So this is gonna be plus 1. This is gonna be x minus 1. And this is gonna be x plus 1. There. So if, right, plus equals isn't defined, does it have include? Include for, right, we can merge sort of two hash sets. So we can do this and this. I'm not sure how efficient this include operation is. It might be super slow. Actually, there's no point in having this be the full set of points. Is there? Well, yes, there is, because we're going to be passing it in as we go. I think we actually have a, right. So functions, functions, as you can see, it complains that basin size accesses the global state of the grid, which we aren't allowed to do. Could do this and just say that we take in this grid. It's going to be passed by reference anyways. And then just pass this grid along. I'm not sure if this is going to work because, or it should work. It's just going to do a lot more work than is required. Because since this is recursive, what is going to happen is that, okay, result is equal to all the points that we have visited thus far. Then we include x and y. So this point is visited. Then we run this basin size again with our result, which then comes in here. Now it has 2 points in it. And as long as this doesn't trigger, we're going to add a third point. And then let's say that returns. The next one is a 9, so now we have 4 points in here. We go down, maybe we're at this position. No, yeah, so we continue. Now, that should be good. I think this should work. So yeah, basin size returns now a hash set of all the positions that were visited in our set. So if we do this, and this means that this is the smallest one in the area, I just want to echo out the basin size. And of course, the basin size is now going to be xy. Basin points is just going to be an empty hash set. I'm not sure how we define an empty hash set. Obviously, it's not nil because it's not a pointer type. Can I do... Is there an init one? To set, so you can convert the keys as an open array to a set. Init set. Yeah, this is what we want. So we just do init set. It's just going to give us an empty set of tuple. Let's define a type here called position, which is a tuple of x and y int. So we can do this, position and position. Down here, we can now do this instead of having to type out that definition all the time, and just pass in our grid. So, oh, this needs to be called as well. Init set is deprecated. That shouldn't really matter too much. Oops, run number 2. Grid sexuent 8. Right. So I messed up when I typed this definition. This should have been a uint 8 instead. Let's see what the error is now. Nothing. Okay, so I'm not sure what LSP is doing here. Deprecated. Oh, right. It's just a deprecation warning. Init set was deprecated, so it should be init hash set instead. Right. So now we can compare this to our input. So if we do this, put it side by side, make sure that that is the full thing. We can now here see that we have 1 0 0 0 0 1. So 0 0 1 0 0 1. So this one is good. And then we have this other one, which should be either that is probably this one or this one. Yeah, this is this one. So that is from 5, 5, 6, 7, 8, 9. That's this line. Plus 6, 1 is there. And then we don't have a 7, 1, but we have an 8, 1. So this looks like it's correct. This looks like it's giving us the right thing. Of course, it's called basin size, which is a bit weird. Let's just call it basin, because it doesn't really return a size. It returns the entire basin. Something like that. We could, of course, define a version of this. Do this. So nym has function overloading. So we could do this. And move this up here. Like so. And now we could just not do this stuff. Right, so because this can't be a func, it has to be a template because it grabs this global variable. We could also make it a template. But yeah, this should still give us the same result. That looks good. So now we can, of course, do basin.card. So the cardinality of the set, or the size of the set. And that should give us these sizes. So 3, 9, 14, and 9. And this is just the risk that we're echoing out, which is not correct anymore. And now we need to find the 3 largest ones. So a couple of ways of doing this. We could either store all of the sizes and then just pick the top 3 at the end, or we could store 3 numbers and then replace them if it's bigger. So I'm going to do that just for fun. Call this biggest basins. It's an array of 3 integers. So let basin size, and then for I in biggest basins dot items, so mutable items. So if basin size is larger than the size of this basin, then the size then the size is equal to basin size, and we have to break out of this loop so we don't set all of them to the biggest one. Right. That should yield us the 3 biggest basins. 14, 9, and 0, which is not great. Right, because that replaced... So it can't... My dog barking. So what happened here was that it put 3 in this position, then it got the 9 and put it in, like, overwrote it with a 9 instead of, because these 2 are still 0. That is a bit of a pain. So you need to track if we have set any of them yet. That is super annoying. Okay, sure. Current basin 0 for I in 0.2, and then we do the template for size, which returns an int, and this is now the biggest basin's current basin position plus the I modulo all that by 2. And then that should be correct. No? Oh, of course. So increase the size of the current basin, or the position of the current basin. Still not right. Wait, why didn't that work? So this should have gone 3 is the biggest basin, put that in position 0. Then 1, and then 9 is bigger than the 0 in this position, so set it that. Then it should have increased once more and said 14 is bigger than 0, put that there. And then it should go 9, wrap around. 9 is bigger than the 3 that is there, and set that to 3. What is going on? Biggest basin, current basin, plus as I modulo 2, so 0, 1, and 2. Did current basin just grow too big? No, that's just they'll wrap around. What the hell? Think about this current basin. 0, 1, 2, 3. and echo out, just so that we can tell them apart. So for this one, it sees that the size of the first position is 0. Says that this goes to a 3. Oh, mod, of course. This should be mod 3. Because if it is the same, then it wraps around. There we go. That's the correct logic. Okay, so now we have the 3 biggest basins, and now all we need to do is time that together. So we can either do it like that, or we could do fold left. It, and then, wait, A plus B? Something like that. It should be times 5, but yeah. Checking that it worked. There we go. So timing all those together should yield 1, 1, 3, 4, which it did. Fold left is just apply whatever this is to 2 numbers at a time, replacing the number by the result of this, and then do that from, so to you guys, from the left all the way down to the right. In this case, we could of course also use fold right, which does the opposite thing, because times is communicative, I guess it's called. But in this case, we can just do this. Okay, so that should be correct. So let's try and run that on our actual input. That took a hot second. Oh, that's not the right answer. Let's move this back here. My answer is too low. Answer is too low. Is this just a matter of this being implemented wrong? We should find the 3 largest basins. Let me just quickly, just to make sure that we're just not doing something silly. Biggest basins is a sequence of integers, or it's just all basins. And then basins.add the basin size. Hey, just a sec. So yeah, this is the dog that I'm watching. She wanted to come up and say hi. Yeah. So this is the little dog that I'm watching. She's super tiny. And she really likes to be next to me when I'm doing stuff, or on top of me. Right. I guess that I can't move closer with her on my lap. Yeah, I guess she's touching the microphone as well. So what are we doing wrong here? We add the basin size to there. I'm just gonna import algorithm. Wait. Just dropped her back in the sofa. She was getting wriggly, and I couldn't sit close enough to the mic. So import that. Nothing. She was digging in the sofa again. Basins.add, and then echo out basins.sorted, which I guess, no, undeclared field. Wait, isn't that in? Oh, it's just called algorithm. Ah, right. There. So that should give me all the basins. And I want to also get the ones that I found as the biggest basins. Just see if those match. And they do not. So yeah, my algorithm was apparently wrong. This should have been there instead. Okay, so we're just not gonna do this. We're just gonna do it the easy way. Just add the size of the basins, sort them all, and then echo out. Just do a in place sort, and then take the highest number times by the second highest number times by the third highest number. This should be our actual result, which is bigger, and it complained that it wasn't big enough. Hooray! That's the right answer. 1 gold star closer to finding the sleigh keys. So yeah, that was it for day 9. You can see the cave here is starting to get more and more color. If we go to my GitHub here, this is my GitHub. You can find all my solutions here. So I'm going to upload day 9 when I'm done streaming. Here, there's also a link to a YouTube playlist where I put all these videos, the recordings of these. So if you want to watch some of the other days, you can go there and check it out. I have to cut this stream short here because the dog is, I don't know what she's up to. I think she wants to go out. So I'm gonna upload and do all that stuff later, but we can't look at any other cool solutions right now. But yeah, that's it for today. Hopefully you're still having a good Advent, and hope to see you in a future stream.